Hi, this is Kara, and I'm going to be going over ionic bonding, ChemQuest 19, and Skill Practice 19. So first off, an ionic bond occurs between a metal or transition metal and a non-metal. The metal is usually the cation, and then the non-metal is the anion. And in the example below, we see that the opposites attract. So if we have a positive ion, such as sodium, and a negative ion, such as chlorine, then they'll form a compound, which is sodium chloride. Same with magnesium and fluoride, but for this one we use a subscript. Subscripts are numbers that determine how many atoms of an element are in a compound, and since we need 2 of the fluorine atoms to make the compound neutral, we have to add a 2 subscript and a 2 coefficient. So we have MgF2, magnesium fluoride. So naming the ions, the positive ions, or the metals, are the parent ions, and we name them by just using their element name and then adding ion to the end. So Al, aluminum ion, Mg, magnesium ion. The negative ions are different because we have to change the ending of the element name to "ide". So for instance, we have oxide and chloride. Oxygen changes to oxide, chlorine changes to chloride. If we were to practice this, all you have to do is really change the negative ones. So fluorine changes to fluoride, chlorine changes to chloride, nitrogen changes to nitride, sulfur changes to sulfide, and phosphorus changes to phosphide. All the positive ones will stay the same, and then you add ion to each name. Finding the overall charge of compounds, you just have to add the charges of each ion. So if we have 1 sodium ion, which is positive, and 1 chlorine ion, which is negative, we have 1 positive and 1 negative, and that will result in a neutral compound, sodium chloride. If their subscripts are coefficients, then you have to multiply the charge by that number. So for instance, magnesium and fluoride again, there's 2 of the fluoride ions, but they're negative, so we have 2 plus on the magnesium, and then -1 times 2 gives us 2 negative on the fluorine, which is renamed fluoride, and then +2, -2 results in a neutral compound. The resulting charge of any ionic compound will be neutral. So just keep that in mind. If we work on making bonds neutral, we just have to cancel the charges like before. So if we're given calcium and nitrogen, we just have to find the lowest common factor of 2 and 3, which is 6. So we would multiply calcium by 3 to give us a +6 charge, and nitrogen by 2 to give us a -6 charge, and then in the problem you would add a coefficient, so 3 calcium, 2 nitrogen, and then the result calcium nitride, and then change the coefficients to subscripts. And the resulting charge will be neutral because you'll have +6 and -6 charge on each. Writing out formulas correctly. So the 2 rules is when you're writing a formula or naming a compound, the positive ion is always listed first, and then secondly, the overall charge of the compound will always be neutral. So if we look at the mistakes from these compounds listed, we just have to kind of manipulate them to find the correct answer. So on Al2S, the charges aren't balanced because we know S is -2, Al is +3. So it should be Al2S3. For phosphorus sodium, the positive ion is listed second, not first, so we just have to switch them around, and then we have sodium and 3 sodiums and a phosphide. For Mg2S2, it is balanced but not simplified, so you can just take away the subscripts completely and leave it as MgS. So more practice on this is writing the formula and name for each. I'm just going to say the names because I wrote out the formulas in the second part of each and showed their charges. So nitrogen and sodium, sodium nitrate, barium and sulfur, barium sulfide, or the first one actually is sodium nitride, that was a typo. Magnesium and iodine, magnesium iodide, oxygen and aluminum, aluminum oxide. You had to switch those because aluminum is positive. Calcium and phosphorus, calcium phosphide, sodium and sulfur, sodium sulfide. Next is finding the charge of an unknown ion. So if we know S is -2 and we need to make it neutral, then we need X2 to be +2. Since there's 2 of them, then X is only +1. If Mg is +1, then we just need one of the opposite, so X is -1. P is -3, and there's 2 of them, so that's an overall charge of -6. And then we need X3 to be +6, and since there's 3 of them, X will be 2+. So writing the symbol and charge for each. So you can just use the periodic table, which I'll show later, to find out the charge on each of the ions here.